In part B in this question, we're asked to delve deeper into the actual technique from getting the data to show us what the frictional torque is. So it's really a specific description about how we use the data and measurements to get at this. And just to reiterate, the formula we're operating with is torque is I alpha, and we know the I alpha is proportional to mr squared. We already have those values, but how do we specifically get the alpha? Well, alpha is defined as delta omega over delta t. And we're going to use a graphical approach from this to get the alpha. And so if we have a graph, as we described in the beginning, we have our omega and we have t. We said that the first time around it would travel rather quickly, so the time would be short. And so we have the period for that first interval, and we have 2 pi radians, so we can get the average angular velocity, which is 2 pi radians over that period for the first interval. And so that average omega would go with the midpoint of that time, that period. And so we have some value like this, our data point. And then the next time around, the period will be a little bit longer, and we will go to the midpoint of that period and plot that like so, and the next one would be longer still. And again, we're looking for at least 5 different rotations, get 5 different points here to establish the trend, but we're always plotting that omega with the midpoint of that period. And now analyzing our graphs, remember we always look at 3 attributes of every graph to determine the things it could tell us. There's what we can read, which is the axes. So any question about omega or time we can get simply by reading off the graph. The gradient, or the slope, in this case, is delta omega over delta t, which is alpha, the acceleration, and the area in this case is omega delta t, which is delta theta. Now, of course, we're looking for alpha here to complete our analysis. So when we have our points plotted like so, we can then find the slope of the graph, and that will give us the alpha. And so specifically, once we have that alpha, we multiply it by the mean values of the the m in the r squared, and we get the alpha and therefore the torque.